Καλησπέρα για από μένα. Θα ήθελα με πολύ μεγάλη χαρά να σας παρουσιάσω έναν από τους επίτιμους προσκεκλημένους μας, τον Γιούκα Πετρετζαβάνιο, ή JP όπως το μου αρέσει να τον λένε οι φίλοι του, ο οποίος με πολύ μεγάλη χαρά δέχτηκε την πρόσκλησή μας για να έρθει στο ένατο πανελληνικό συνέδριο και να μας παρουσιάσει τη δουλειά του. Ο JP είναι ένας από τους μεγαλύτερους σύγχρονους ερασιτέχνες αστροφωτογράφους παγκοσμίως, με πολύ μεγάλες διακρίσεις. Οι φωτογραφίες του έχουν δημοσιευτεί σε πολύ μεγάλα έγκυρα περιοδικά, όπως το National Geographic, το Report, Sky and Telescope, Universe Today, Daily Mail, Discover Magazine, Wired Magazine και ούτω καθεξής, πάρα πολλά. Αλλά αυτό που θα ήθελα να πω είναι ότι αυτό που το ξεχωρίζει είναι ότι, όπως το λέει ο ίδιος, η αστροφωτογραφία για εκείνον είναι art form, δηλαδή μια μορφή τέχνης. Και αυτό οφείλεται κυρίως στο καλλιτεχνικό υπόβαθρο που έχει. Οπότε, ο ίδιος δεν θέλει μόνο οι φωτογραφίες του να έχουν την αστροφωτογραφική αρτιότητα, ας το πούμε έτσι, αλλά φροντίζει ώστε να συνυπάρχει αυτό το στοιχείο με το στοιχείο της αισθητικής ομορφιάς, της καλλιτεχνικής φαντασίας. Έτσι. Όλα αυτά να δημιουργούν μια σύνθεση και επιστημονικά άρτια και αισθητικά όμορφη. Ο ίδιος κατάγεται και εργάζεται στη Φιλανδία, στην πόλη Ούλου, στο κέντρο της πόλης μάλιστα. Οπότε, λόγω της έντονης φωτορύπανσης που προφανώς μπορεί να φανταστεί κάποιος ότι συναντά σε τέτοια πόλη, η δουλειά του περιορίζεται δυστυχώς σε φωτογράφηση νεφελωμάτων εκπομπής μέσω φίλτρων στενού φάσματος, να πάνω δηλαδή, έτσι. Η ίδια η πόλη, στη Φιλανδία, βρίσκεται πολύ κοντά στον αρκτικό κύκλο, που σημαίνει ότι παρουσιάζει το φαινόμενο ώστε να έχουμε 6 μήνες νύχτα, 6 μήνες μέρα. Αυτό έχει τα πλεονεκτήματά του βέβαια, 6 μήνες νύχτα δεν είναι πολύ κακό για κάποιον αστροφωτογράφο, αλλά παρόλα αυτά, συγχρόνως με αυτό, το σκοτάδι συνοδεύεται από πολύ δύσκολες καιρικές συνθήκες, μπορεί να πει κάποιος. Πολλές φορές συναντά ένα μέτρο χιόνι, ας πούμε, στο παρατηρητήριό του, ή ακόμα και θερμοκρασίες μπορεί να φτάσουν τους -40 βαθμούς. Παρ' όλα αυτά, ο JP καταφέρνει ο μέσος όρος των φωτογραφιών του κάθε χρόνο να κυμαίνεται γύρω στις 10 με 12. Και αυτό το καταφέρνει όχι με κάποιον υπερσύγχρονο εξοπλισμό. Μέχρι προσφάτως χρησιμοποιούσε ένα παλιό μοντέλο της MID, ένα 12 με GPS, και με κλασικούς φωτογραφικούς φακούς. Πρόσφατα έκανα μια αναβάθμιση στον εξοπλισμό του, αλλά μέχρι στιγμής όλες τις φωτογραφίες, τις οποίες μπορείτε να δείτε ένα δείγμα έξω, είναι πάρα πολύ όμορφες και έχουν γίνει μόνο και μόνο με αυτόν τον σχετικά απλό εξοπλισμό και πολύ μεγάλη προσπάθεια. Αυτό που τον διακρίνει είναι ότι για εκείνον η αστροφωτογραφία είναι πάθος, και αυτό μπορεί να το καταλάβει κάποιος απλά συνομιλώντας με τον ίδιο, γιατί είναι ένας άνθρωπος με πάθος και όπως το ομολογεί η ίδια του η πορεία στη ζωή, η οποία είχε πολλά σκαπανεβάσματα, και όπως είχε πει και ο ίδιος, η αστροφωτογραφία ήταν αυτό που τον κράτησε σε όλα αυτά τα χρόνια. Μπορώ να μοιραστώ μια ιστορία από τον ίδιο, όταν την παρέλαβα στο αεροδρόμιο, μου είπε ότι τις προηγούμενες 5 νύχτες είχε μείνει ξάγρυπνος, επειδή έτυχε οι προηγούμενες 5 νύχτες να έχουν ξεστεριά και δεν ήθελε με τίποτα να χάσει αυτό το πράγμα. Ήταν πολύ πολύτιμο για αυτόν. Την Κυριακή ο JP θα μας κάνει ένα workshop για τις ειδικές τεχνικές που έχει αναπτύξει, αλλά σήμερα θα μας πει κάποια πράγματα για τον ίδιο, για τη δουλειά του, για το παρατηρητήριό του, και θα μας δείξει κάποιο δείγμα των φωτογραφιών του και να μοιραστεί λίγο το πάθος του για την αστροφωτογραφία. Οπότε, χωρίς να καθυστερήσω άλλο, θα σας παρουσιάσω τον JP και να σας πω ότι οποιοδήποτε η παρουσίαση θα γίνει στα αγγλικά, αλλά όποιος έχει οποιαδήποτε ερώτηση ή απορία μπορεί να πει και να κάνουμε τη μετάφραση ανά πάσα στιγμή. Οπότε,
Okay, thank you. It's so wonderful to be here in Crete and in Sparta. After living in Finland, it was -6 degrees and very windy. It's amazing to be here in the summer again. So I'm a Finnish astrophotographer, and I call myself, sorry, this is in English, I don't speak in Greek, nature photographing. Astrophotographing is a form of nature photographing. I can show you a lot of pictures, but before that I show you where I am working, what kind of conditions, and with what kind of tools. Actually, this is my... Find the laser pointer here. Thank you. Sorry, there's a technical problem. This is typical to astrophotography. So this is my name of my observatory, ASTROSYNEDRIO. There is a reason for that, and I call it my work as a dark side of art, for obvious reasons. And that's my image portfolio in the web. Okay, here I am, and here we are now. This is polar circle is here, so it's just a couple of 100 kilometers south from the polar circle. Okay, now use it. Sounds better. Although this is a little bit closer, this place here. So you can see it is less than optimum location, middle of the town. It's about 250,000 inhabitants and it's industrial town, so there's a lot of life. And my observatory from last winter. It's a typical situation. It's, before I can start photographing, I have to move all that snow. This is my old setup. The meat, I use it about 12 years. It's like a techno-porno, actually. It's not made originally for imaging at all. It's old instrument, it was old when I got it. And it's full of modification to make it work as an imaging scope. All those wires are really needed. Here you can see this yellow fabric, it's isolation for the heater. Otherwise the camera CCD chamber will frost. So I need to put a heater there and I need some isolation for that. Some closer look, this imaging path to see here is a camera. This is QH-Y9 from China, filter field. This is the most important with this fork mount. This is active optics from Starlight Express. Then here is another important piece, that a temperature compensating focuser, because in Finland temperature drops a lot when it's clear and night starts. It can drop up 20 degrees in an hour. So our telescope is glitching, so you need to compensate it. And here is another homemade tool. This is the camera lens, Tokina 300. This L-shaped metal is from old table, and that's the focuser, and that's the file, and that's the spring lobe. So this rotates the focusing ring and compensating the temperature shift. Most of my pictures you will see are taken with this instrumentation. This is my new instrument. The old one destroyed spring 2014. It was a massive shortcut, and 10 years in city air has corroded all the optical surfaces, and it was beyond any repair, reached any reasonable amount of money. I got a new system. This is Celestron Edge with A4a U16 camera, which is a wonderful instrument. It's the Stradivarius of the Astro cameras. And here's also the active optics. This is the 11-inch Celestron, and the mount is 10 micron. It's a little bit better, but it's surprising me how this makes possible to me to shoot different kind of objects. This is less technical form of photographing might think. You don't need hundreds of thousands of worth equipments to make pictures. And then the pictures. This is why I'm doing this. This is why I'm soldering cords in minus 30 degrees and stay up all the nights and destroy my human relationships. This is why. This is Pac-Man nebula, NGC281. And this is also example what kind of palettes I'm using. This is the natural palette, because all pictures you will see are narrowband imaging. It's visual light, but only in certain wavelengths. So I'm specialized to emission nebulas because of the light pollution. So this is a natural palette, but you can combine those color channels to different order. This is called Hubble palette, where the hydrogen can be seen as green and sulfur as red and oxygen as blue. And this is the center of the, you can see the block globulus here. The gas is collapsing and new stars are born. This is an art for me, but my pictures are fulfilling the scientific imaging also. And why I'm so thrilled about those pictures is that there's several layers in every picture. There's visual layer, the beauty, and then there's a physical layer, and then the metaphysical layer. The whole human existing is in those pictures. This is another example from last winter. This is a Sharpless object 115 in Cygnus. And this is also an important picture for me, because this same picture is a birth and death, both. These new stars are born in here, and that's the planetary nebula April 72. There's not too many pictures of this object, generally. The image field is about 1 square degree, so the full moon is about quarter of this picture. Here is a close-up from the birth. Here is a star cluster responsible for the ionization. And here is a close-up for the death, the planetary nebula. The small suns, like our sun, dying like that. I'm sorry, I changed a little bit settings of this system. It takes a few seconds because I'm a perfectionist and I don't like if there's too much contrast. Take a few seconds. Okay, it's good enough. Yeah, let's go on. As you see, it's my passion, but I'm sometimes too neurotic with my pictures. This is also an interesting picture. This is a monkey head nebula, but it's never seen like that. Usually you see this part of the nebula in every picture. This is never pictured before. It is really dim. I use a new technique for this. It's called variable resolution imaging. I won't show it today or this conference. It's still under work, but it makes possible to have a huge signal in a relatively short time. This is only about 15 hours of exposures, the whole object. Here's the same object in the natural palette. Another one. This is taken with talking objects, camera optics. So this is very large in the sky. This is California nebula NGC 1499. The full moon is about this size compared to the object. Many people who don't know astronomy about very much, they ask how much your telescope is magnifying. And actually magnifying is a problem when you shoot large nebulas. You need more light, but less magnifying. And there is, by the way, there is a planetary nebula candidate. I reported it back in 2008 or 7 when this picture is taken. This is a close-up. This is how I work. I select an object or location in the sky, and I take wide field of pictures, and then I use different focal lengths and go near the object. So I can spend a year with the same object. You will see examples. This is the mosaic of Auriga. It's about 14 panels and 90 hours of exposures taken with the Canon 200mm camera optics, f1.8 full open. And here is the CMACE 147, the supernova remain. Here is IC 405 and 4010 and 405. And here is some sharpest objects. You will see close-up images from these areas here in this presentation. We go a little bit closer. This resolution is amazing. You can see all those dots are stars. Are we going closer to this formation? Here. And here. I call it the cosmic fertilization. So this is like the cosmic sperm. And it's making new baby sons. And it's actually true, because this cluster here is responsible for the whole ionization. And the radiation pressure is driving the gas away. But here the gas is collapsed, and it can resist the solar wind. And because collapsed heads they are places for new stars to start forming. Let's go even more closer. And the scale is amazing. They are about 10 light years long each. The black nebula you can see here, it's just the same gas, but it's not ionized, and it's front of the ionized gas field. This is another object from the large formation. You can see it here. It's like dream-like. There's very few pictures out of this. That's why I love it. I can reveal something hidden beauty in the sky. There is some pictures I use as a reference, but usually they are taken for the scientific purposes, and they are not very aesthetic. This is the flaming star nebula, and you can see the reflection nebula component here. Even though this is a narrowband image, I shoot a couple of hours of blue light to show the reflection nebula. It's like the red velvet. And this is the sharpest object. There are very few pictures out of this too. And actually, the blue dot there is a planetary nebula, but it's much more further. It's behind this nebula. Heart and soul in Cassiopeia. One of my favorite fields in the sky. This is taken with a 200mm Canon, and we are going first closer the Heart Nebula. This is 5-panel mosaic with 2000mm focal length. This is extremely detailed image, and we are going to this area. This is my favorite part here. This is Melopte 15. It's like a dancing queen. And let's go in closer. This cluster here is called Melopte 15, and it's full of very massive young stars, and the radiation pressure and magnetic field are twisting the gas here. It's amazing. It's so beautiful. It's even more closer from there. The exposure time for this was about 15 to 20 hours for one panel, and there's 6 panels in this picture. This is another part from the same picture. You can see there. It's called a fish head nebula sometimes. It's like dark dust lanes forming a bridge over this area. Here is a star-forming region. And a little closer, it's very interesting shapes. I took this picture last winter. And the soul. No soul without heart, and no heart without soul. This is two panel mosaic, and the full moon is this size in the sky. We go a little closer, interesting areas here like a mountain with interesting shapes. I can study those pictures endlessly. And this is the way, actually I have to say I feel very naked to being here showing my pictures, because they are on the line, but it's very anonymous. People get looking then, and now I'm showing here. It's like showing my naked pictures here. To look, this is me. No, but it feels, it's fun. But every time I have the same feeling, like being naked. This is another of my favorite pictures. This is actually a cosmic question mark. It feels, for me it means, it's like me, I'm very curious. And they are well-known objects. This is cheddar blood 214, and this is a sharpest object. But nobody wasn't, at least I haven't seen any pictures where they are together. This is one frame, of course but one field from the Canon 200mm lens. So it's perfect question mark. This picture gets published by the National Geographic. And we are going close to the data part 214 here. This is star cluster, and you can see that almost for every time the emission nebulas have the same structure. There is a star cluster which has born from this gas, and now when it's born, the radiation pressure is driving the gas away. That's why all the pillar-like formations are pointing the source of the ionization. Even the small ones. Yeah, they all are pointing. And this is a little bit more close up from the picture. Rosette Nebula. This is difficult for me because it's very low in Finland. The maximum elevation is about 30 degrees. Narrowband image. And from the center, same structure, hollow space around the gas. Another big mosaic. This is Cepheus. You can see Elephant Trunk Nebula. This is IC 1396. This is Sharpless 132. Bubble Nebula can be seen here. Gale Nebula. Witchhead Nebula. I have a series of pictures from this area. So this is the big mosaic, 16 panels, and total exposure time is like 100 hours. This is one part of the mosaic. Here you can see the elephant trunk. This is the recently found planetary nebula candidate. It's Nicholas Alter from Germany. Nicholas Alter. There's not too many pictures this year. Let's go closer to the elephant's trunk. This area here, this is a very massive area of sky. And this is very sculptural formation. And the next picture is funny because I got this ready last Wednesday. That's why I was so tired when I arrived. I think it's amazing sculpture and with amazing scale. This is about 25 light years. There is new stars forming and making a hollow space at the tip of the trunk. And actually, I was surprised to see those shapes here around the black dust. I haven't seen them in many pictures. There's like black wings here. This is brand new. This is a world premiere for this image. I haven't published it yet anywhere else. This is a close-up from the detail. It looks like the same, those creatures they use in the churches, like in Notre Dame, gargoyles. They call gargoyles. Wings and feet. Yeah. Okay, another interesting. This is very old picture from 2006, but I selected here because this pearl here is so brilliant. It's a bubble nebula. This is bubble nebula in visual spectrum, and this is in Hubble palette. And this is taken with old meat. This star here is responsible of this everything here. This is funny. It makes my head spin. This object. This is about 8 to 10 light years diameter. This bubble, and it's really a bubble. It's a shock front, and it's expanding 2,400 kilometers per second. That's not a scale mistake, it's really per second. I calculate how much bigger this will be after 100 years if I use the same tools and take another picture. It's 1/2 of the pixel. So 2,400 kilometers per second is not very fast in this scale. So how this has formed? This star is relatively young, maybe a couple of millions of years. It's formed from this gas. And after the gas collapses and nuclear fusion starts, this is a very massive star. It blows the gas away, and it forms a shock front. This is very temporary phenomenon. There's others, but this is most striking one. This is Surplus 132 in the same area. And this is old picture taken with the docking object. And you can see the oxygen, it's very interesting how it's separated. And there's funny looking arcs here. I don't know what they are. And O3, so ionized oxygen yet. I took a close-up picture last winter from here. So you can go back, you can see this bright spot here is same as this here. I rarely gave any names to my pictures, but this one I gave a name. This is, in English, the name is "The Furious Cosmic Horse Gets Blinded by a Divine Blue Light." You can see the horse head and legs here. It's getting really pissed off because of that light. There's something really interesting in this picture. This is another rarely imaging object. This is NGC 1491. Star forming area, very dim. The Wizard Nebula. This is close up from the Wizard. You can see this is a hat and nose and hands and legs. Those names are given back in the 17th century, so when they are purely visual, they don't look much anymore like those old texts. This is actually my biggest work so far. This is the whole mosaic of the almost whole Cygnus, constellation Cygnus. The scale is huge. Full moon is this size. This picture. This is 18-panel mosaic. And it's about 24,000 pixels this side and 18,000 this side. So it's very detailed. Here you can see the North American nebula, the death and birth. I saw you. The Surplus 115 is here. The planetary nebula can be seen here as a dot. It's the Butterfly Nebula. This is Crescent Nebula and Tulip Nebula, and lots of other stuff. Actually, this area here, it's never been imaged by it as an own object. There's thousands of light years long filaments. Let's go closer. Oh, this is a print out of this picture. This is about 4 meters times 1.8 meters, and it's very sharp. There's no blurring. Another picture out of it. It's printed on aluminum. This is close up from the upper part where the filaments are. They are really, really beautiful. At the moment I'm shooting this part here. And here is a recently found supernova remain. In this area you can see some oxygen. Yeah, I don't know if they are related. But they are thousands of light years long filaments. I don't know what caused the phenomenon, but it's huge. Here is a propeller nebula. And if we go even closer, you can see the resolution. This is from the particles. All the dots are stars. This is narrowband image. Total exposure time is about 128 hours. Here is the picture from the filaments. This is 10 meters long and 3.5 meters high. And it's still sharp, it's not blurred. There's no big people on the scale, but a man is this size. There are close-ups from the big mosaic. This is so these pictures are hard to recognize, but this is North American nebula, this is Pelican nebula. Here's a Great Wall. Here's the Pelican nebula details. This is a close-up from the Great Wall. Here's another close-up from the Great Wall. And this is the Pelican nebula. And we go closer. This is taken last winter. I concentrate those dust lanes, not so much to this ice-striking formation. But this is like framing the whole thing. It's very, very delicate. And this is black because it's front of the ionized nebula. It's the same gas, basically. For those who don't know what ionizing means, it means that the reason I can take those pictures is that the gas clouds are not lit by the suns. The radiation from the suns makes it glow. The phenomenon is exactly the same that happens in fluorescent tubes. So the gas is glowing, and the gas is glowing at exact known wavelength. So I can cut out everything else and let the true just the one tip wavelength. That's why I can do it in city, inside the city lights. Unfortunately, LEDs are going to destroy this because LEDs are emitting light in all the wavelengths. So far, the city lights are mainly a high pressure sodium or mercury, which are different wavelengths than I understood. By the way, I have no idea how long I've been here. Just let me know about 15 minutes before I have to stop. This is close up from the Pelican nebula. You can see those, they are about 10 light years long, those formations. This is just the color image I need. I should need to shoot the same target 3 times to have a color image. I should ionize oxygen, O3, then I should sulfur, S2, and then hydrogen, H alpha. And this is just H alpha picture. Black and white. This is another area from the Great Mosaic of Cygnus. This is the interesting object, NGC 6888, the Crescent Nebula. We go a little bit closer, and closer, and closer. This is taken with oat meat. This is really violent happening. This diameter is about 24 light years. It's also a shock front. The outer layers of this star is blown away. This is the Ray-Wolf magnetar, a massive, massive star. It's like a film, actually like a film star. It's so massive, it lives fast and dies young. So it's not going to live very long time. It can go off in any seconds or next 100,000 years. Nobody knows, but this is so exciting, complex set of gas. Another object from the same Great Mosaic is here, which is actually one of my favorites. This is Tulip Nebula, Sharpless 101. And why it's so important to me? This picture, by the way, it was the astronomical picture of the day by NASA last year. This is close-up from the picture. It's easily tell here. In this picture you can see, okay, emission nebula, typical. But what is this formation here? The bright dot here is not a star. It's a black hole, Cygnus X1. Or black hole candidate, let's say, let's be honest. Black hole candidate. And this arc, which is not very often imaged, it's a shock front from the jet. There is two jets coming out of the black hole. They are X-ray level, so they can't be seen in the visual picture. But you can see the effect. This is a shock front when the jet is bumping into interstellar gas. In this size, you cannot see it because there is less gas here. It can pass free. But this is Cygnus X1, the black hole. This is close up. Black hole is here, a different orientation. And after that we can go for one of my favorite object type, the supernovas. This is the Whale Nebula in Cygnus also. This is taking a 200 millimeter cannon, and full moon size is about this size compared to this picture. Full moon has an apparent size about half a degree, 30 arc minutes. So this picture is about 5 arc minutes from 5 degrees from side to side. Here is a few others I have shot closely. This is Witchbroom Nebula nickname, the western part of the whale. This is Pickering's Triangle, and this is the eastern part of the Whale Nebula. I have close-up pictures from here. This is actually the same here. It's called the Network Nebula, is the nickname for this. It's interesting. This is also a shock front. It goes this direction, a little bit over 1,000 kilometers per second. And you can see oxygen as blue and yellow. Goldish hues are mixture of hydrogen and sulfur. This picture actually was selected a year ago as a third place in a competition organized by a Royal Observatory, Greenwich. This got a third prize, which was amazing wonder because I stood from the rooftop with the old meat, and the other instruments were like 2 meters, mirror and wonderful conditions, 300 kilometers per year. And this is close up, so it's very detailed picture. Another picture from this is the Pickering's Triangle, but why it's blue? This is only a blue channel. This is only a ionized oxygen, O3. There's nothing else here, just O3. Here's a close-up with O3. And when you add hydrogen and sulfur, you got this. You can see the oxygen still here blue. This was an astronomical picture of the day by NASA 2 weeks ago. And, well, you read my observatory name was Astro-Anarchist. I do my pictures whatever I like. This is the same picture without stars. When you turn off the stars, you see the details better. Here is a close-up from the center. All those filaments. Actually, this is a very effective tool if you want to hunt a very dim, very old, very diffuse planetary nebulas in a Milky Way plane. There's a very dense star field. You can remove the stars and you can have a good signal from whatever you like. I use this as a tool. So it's stars without stars. This is the Witchbroom. Also a very new image from this autumn in natural colors. This is in Hubble collected details from the Witchbroom. Yes. Then the older picture, this is M1, Messier 1, the Grappling Nebula, supernova remain. This is taken 2000 9. Oh, this is one of my favorites. This is Siemens 147 in Ox, constellation Taurus. This is huge. Full moon is this size. It barely fits in the field of the 200mm camera optics. It's about 79-hour exposure time with all 3 channels. This is sometimes regarded as the holy grail of the astrophotographers because this is really difficult. It has so low surface brightness that it's almost nothing. It's very near the background level. Here's a close-up, and you can see there's also oxygen here. It's very rarely photographed. The 3-band picture. This is not supernova, this is planetary nebula, Messier 27. Taken with the old meat. This is also maybe 7 years old picture. Even closer, you can see here. This is a white dwarf, the pure iron core of the dying star. Outer layers are here. Here you can see the core. It's glowing white because it's so hot. It will turn to a brown dwarf when it's cooling down, but it takes billion years to get cooled. It's so hot. This is another of my favorite objects. This looks much nothing. This is Jones Anderson 1. It's quite large planetary nebula. Full moon is about this size. For the planetary nebula, it's very large. You can see the central star here. I don't know if you see, but there is an outer hollow here, which hasn't been shot before. It can be seen around here. It's also called a headphone nebula. It has something headphone-like in there. Another planetary nebula, Cat Eye nebula. And Nike logo is there. Maybe they start to sponsor my work. And another planet, this is taken with a remote telescope. It's a Buck nebula. It's like a piece of jewelry. All those pictures you have seen so far are taken from my rooftop observatory. This is the first one I use, a remote telescope in Australia. This is taken from the rooftop, M13. This is the first broadband image in this set. This is our remote telescope picture, M31. I had to do it because it's everybody shot M31 except me. So this is one. This is one without stars, but you can see the dots here. It is very accurate. They are the global clusters of M31. All those dots. There's over 100 here in this picture. I want to separate them so. Actually, this picture is how you see Andromeda if you travel outside of our galaxy, because all those stars here are in our galaxy. The maximum distance is a few tens of thousands of light years. But this is 2.5 million light years, so there is 2.5 million light years nothing between there. This is close up from the picture. Yeah. Okay, that's wonderful. Because now you will see something completely different.